Okay, now you see, you write your first program for the beginners, absolute beginners. You write your first program in your life. We call it you can call it code, you can call it program, and in Python we call it Python script. When you collect the see, in Python every single command we are giving is an instruction. So it actually, the computer programming programs use follows this way. These, you give one instructions another after another, and it follows serially. You give one instruction, then if it is used next, then it will give another instruction, another instruction, another instruction. So systematically you have to give one instruction after another, and as if you can think the computer is reading from the top and going down one by one, and if it is to use something above, it will get it there. Okay, before you do something, you have, if you it is something is related to other, if the other is can be written before that. Anyway, so okay, now I write a computer program in a sense. I collect some instructions, and then I can tell that it is a program. I write x equal to 2 and write y equal to 3. What do they mean? This means that the number 2, I am not trying to save it some memory space, and you give it assign it with some name x. Now you don't have to put any quote unquote, because this is now this name is now variable. Whoever have done algebra in life, you can understand this way we write algebra. We do manipulate, we do mathematical operations with symbols instead of numbers. So here x is a variable. You can call it as a variable. So variable name, you can give anything, but there are some restrictions. Okay, I'll tell you. I give the simple names x and y because they are so common. You can write something, some abracadabra, whatever, something. Some say 6, of course, but you don't give. I suggest don't give some such kinds of funny names, because later you cannot remember. Later you begin to have it. But better, it is better that you give some name that later you can understand what it does. You can write my variable say 1 something, so it means my variable 1, so that is say 5. Okay, so if you write my variable 1, it will give you this number back. So it is fetching from the memory location, and you can check everything. So the name of the variables, this is very important. I can tell you in short. Often I see the kids, they are very curious about giving names, and they are very enthusiastic. They give some names. Sometimes you can see, you can give some numbers, 2x equal to 6. It is giving you invalid syntax. That means the variable name should not begin with a number. So rather you can write x2 equal to 6. That is okay. And inside the names, you cannot use the mathematical symbols, plus, minus, star, etc., the special symbols. Only sometimes if you write an explicit name of a variable so that you can later understand what does it do, then you can use this underscore. Okay, you can join them with underscore. Okay, if you write here instead of underscore, if you write here a minus symbol, it will try to think that it is actually doing some algebra, my minus variable, something like that. So don't do that. You'll eventually get to know all those. And also variable names, there are some typical system names, like type is a system name, class is a system name, str is a system name. You do not give these names. Try to avoid these names. You will say, sir, there are some commands, is, in, and, or. These are some operators. So you do not also give these names as variable. So there are lots of, the whole world is there for you. I mean, you can give any name, but don't give these names. Otherwise, it will actually conflict with the system variables, system functions and parameters and something like that. Okay. So now if you write, say, type of, say, I declared, say, again, once again, I write x equal to 2, y equal to 3. It was written, but for you, I write again. So if you write type of x now, it will show you this, this integer. If you now write id of x, id means identity. So it is showing you some number. Don't worry about these numbers unless you are very keen to do. It is actually giving you the address of the memory location. Okay, let me tell you one thing. Like I give x equal to, say, now I type x equal to, say, 7. Okay, now see, before that you write x equal to 2. Now I write x equal to 7. And now if you try to see what is x, now the previous is gone. It is over. This symbol, this tag, you can think this x symbol is a tag. So tag is now on 7. So now you can write id x. It will, of course, show you a different location. See, it was another one location, it was another location. So that way, the first, I think you remember, even the ID is not always very, not useful, not always a kind of will be useful for you if you do simple programs. But this, I find the type function is very, very useful for you, because whenever you see some unknown creature on your program, on your something, on your what is this kind of thing you want to ask? So what is this kind of object? See, this class means replica of class is object. Okay, so you can see this is an integer. So you can satisfy yourself. Tomorrow you'll see Arunabh Adhikari will show you list, dictionary. So all of things. Suppose you have some collection of numbers, you give some name X or whatever. Then you try to see what is this type. Inside type, you see, just to write you something x equal to some, say, 1, 2, 3, suppose. It's a collection of numbers, iterable, of course. And you write type x. So this is a list. So it is showing its character. This, what is this kind of object? Okay. So, well, so again, I write with a simple program 3, and I write z equal to x plus y. And then I write print, of course, you have this a function we call set. Done. Your program is done. So this is a 3-line program. Basically 4-line to x equal to 2, y equal to 3, z equal to x plus y, print z. So this is your first program in your life. You are actually, earlier it was you were doing some typing on as a calculator. Now you actually are keeping something in memory, taking it out, kept something in memory here, took it out, and this is your algorithm that x plus y is equal to z, and this is a new variable name, and now you print the entire program. So eventually we'll see when you write a program in Python. I now talk to other people who have has experience of working in other programs, Fortran, C, C++, whatever. You see, there will be lots of syntaxes, and you have to tell where to end, sometimes where to begin, sometimes you give to curly brackets before an end, sometimes you have to write end of the program, stop it, etc., etc. Python minimizes, thanks to Guido van Rossum, Python minimizes everything. So Python is such a language, there is no beginning, no end. You write, whatever you write is a program. Suppose you are you are not keen to do computer programming. You want to work something for your data, and you are a geographer. You take some data and you plot, and using some function, you will do some calculation. You don't want to write complicated with computer algorithm. You write some lines, instructions. So these are, you never have even think that you are writing a computer program, but this is a computer program. Whatever lines you write, even if to plot graph or something like that. So everything is a computer program or Python script. Now suppose if your program is bigger and bigger, you add many lines over it, do all sorts of things, then it is not always possible to type on interpreter. But I will always advise the beginners that you always, whatever you do, you always keep your interpreter open. This is, you type and see. Yesterday we were asking lots of questions, so beginners. Many of the things you could satisfy yourself while typing on this and see. My suggestion is you type and see what happens. Then try to explore why it is happening. Then go and read the help file and things like that. Everything is here. So now what I do is that I copy this. I copy this. Oh, it is for some reason my interpreter is not allowing me to copy. Anyway, what I do is that you click here on the left top, file, and here is a new file. You go, and the another window will open. So now you write x equal to 2, one instruction, next instruction y equal to 3, and the next instruction x equal to z equal to x plus y. And suppose I complicate the program, x star y minus x by y, something like that. Okay, this is the new algorithm. And you write print. Here you have to write print, of course, because it is not interpreter, because you are writing on a file. And you write z. Okay, this is your program. Now this is your complete code. And if you write this, you run this on your Python shell. Oh no, your Python shell is here. You run module. It will ask first time. It will ask you to save in some name. I give a name. Say for example, I give a name. Say the first program. I'll say first. I'll say first program. First program. First underscore program. Okay. Normally I give test dot thing. And you have already. I don't know whether you can see it, but on your interpreter you will definitely see this. This writing text is so small. These programs will automatically be saved in something .py. That is, it is a Python script, Python code, py. If you work in Fortran, you have noticed the programs will be saved in .f, something .f, file name .f. In C, it is something .c, like that. So it is something .py. So we save it and you run. I mean, automatically it's run. You see this answer. So you have worked here in this file. You have written this here in this file. And where is it? Gone? Oh, where it is, okay. Let's see. Oh, yeah. And the answer will come on the interpreter. So it is answer. The answer. If you can now design your program, like if you write z with inverted comma, z equal to is comma z. That means you write a string inside this, right? So it will prompt like this. It will give it back like you wrote hello Python. So it will just return me z equal to, and then intentionally I give it a gap so that okay, you will understand why. And then there is a comma. So that means inside this print you can write as many arguments as you want. So one argument is a string, then a comma, separated by comma, and then the variable z. This z equal to with inverted comma is a string, and this z is, you see the change of color, this z is your variable. Now you run. Okay, but before that I can also decorate, I mean also do something on that. In Python, it's possible that you give the two things on the same line, x comma y equal to 2 comma 3. That is very nice. You can reduce the line size, program size. Okay. So this is the x comma y equal to 2 comma 3, z equal to this. And also you could write, without even writing this whole thing, you could also write this whole thing here. That means the program would be on these 2 lines. So you can actually minimize the lines, but you don't minimize in such a way that the other people cannot understand, or later you cannot understand. I can tell you a little kind of anecdote. I went to work with Professor Dietrich Stauffer. People who are in physics, and particularly statistical physics, they will learn about Dietrich Stauffer. He's a stalwart. He has books, and he was a director of supercomputer in Germany, and he's a very legendary figure. He died this year beginning or so. Anyway, so I had the opportunity to work with him for a very short time. So one thing he told me, that time I used to write in Fortran, and I wrote some program roundabout way he didn't like, and he told me, look, you write a program such a way that the number of lines should be always less than your age. It was a joke, but of course in Python, we can always do that. We can always write a huge kind of, some work for a program for a huge work in a very short space. The lines number will be very, very small, because we can do all kinds of manipulations. So if you write that, if you suppose it is your program, and also on top of your program, you can write with hash. Hash means comment. That means the compiler behind this will not compile, the interpreter will not do anything. So you write here, this is my, whatever you write, first program or whatever. You don't have to put quote unquote anything here, because it is starting with hash. Anything you hash means this is a kind of comment. So run this. That means later it is a good, aesthetically it is good, that it is a good way of writing program also. Any program you write for future, that later on you open up and you can understand what it's doing. You write that, you see these things, and it is now writing z equal to c. And I intentionally put a gap here. Here, so that it is actually giving a gap. But of course, there is a word called format. I'm not showing it that now. Maybe Dr. Arunabha Adhikari will tell you tomorrow. If I have time, I can tell you how to format. That means how to design your print. You print in such a way that the way you want to see on your screen. Okay, so this is. Or suppose I want to check something. I want to write another, say, Z2, another variable Z2. Say I'm something x star. X. Say suppose I can write x minus y by x plus y. Oops, I would not like this. Yeah, and Z2 also, and then I want to, and then others also. Say other also. So I want to write, say I'm showing it something. Z equal to 1 equal to, say, x plus y, something, some three things. Okay, z1, z2, three different variables. And you written, and I can also type here z1, z2, z3, whatever, doesn't matter. But I'll tell you that I do not want these two lines now. I have written, but I want to keep it. I don't want to delete it. But I could do it. I could do hash and hash. But I will show you another clever trick. You can do it with triple quote. Triple quote, moment you do type, it will show you the color change in this here. And you put these two things to separate it out. I just show you for beautification. This is for beautification. So this piece of this block of quotes I don't want now, but I reserve here. So I put in three quotes here, and the color is now green, no problem. So I have xy, and I've calculated z2. I can write z2. I write z2. I now write run, and you see, and so z2 equal to minus 0.2. So here it is. So this is how you write your Python script in a file. So suppose now you come out. You can come here and exit, close. But with Windows doesn't matter. If you cut it, it will go. And now later on you come back after T, and then you say, okay, I want to see that file. Okay, let's see if we go to file. Then you want to open that file. Okay, so now go to open. Now this time it is not open, new file is open, and see this file is there. You see this here. If you can see, you will see this first program underscore program.py is here. You just click it, open it, the program will arrive again. You can modify it, save it, and open and use it. So that's why when you write a program of few lines, you can actually go to file and write in this file, and this way you store your bookkeeping, your files in a systematic way, that you, whichever programs you write in your life on your separate directories and things like that, etc., etc. Later we'll show you how you can write modules. The programs itself is a module. Okay. Anyway, so now these things is you see. I'll again come back to the on interpreter because it is easier to show you. Okay. So on this interpreter, you wrote, say, x comma y equal to 2 comma 3, right? But suppose you write a program that you don't have to go every time here in the file, then go here and open, and then again you go type x, y, you instead of 2, you write 5, say, or something, 3.8 or something, you change and then see the result, suppose, okay? So every time you don't have to open this, if your other part is remaining intact, it is foolish that you go inside every time and change the values of the variables, okay? Not values, actually, the numbers, I mean, which are assigned as x and 2, okay, quote unquote value. Okay, so in this you don't have to do that because you have a function called input. You can take input. Suppose you write x equal to input, right? This is a function, right? You can give a string here. The string will be a prompt string. What is prompt string? That means you can write something for yourself. You write enter the value of x, okay? Okay, so it should be a full stop, okay? Okay, so if you write this, see, it is waiting for you to give the value. So this thing you have, that means you will know, okay, I have to now enter the value of x. So then you give value of, say, 4.5. It is now, x is now 4.5, okay, etc., etc., okay? So but you see, notice one thing, x, look at the you can suspect that this is something else. This is surrounded by two strings, but this is in Python 3. In Python 2, I'll tell you, it is a number. It is a just pure number. But here it is a string. Why it is string? That I'll tell you later. Python takes every input as a string. Why? I'll tell you. Okay. Okay. But before that, to test your type, put x inside and see, this is a string. So this string cannot be done. See, if your y is suppose 3, and if you want to write x plus y, it won't work because you are adding apple with pears. This is x is string and y is given this number. It was 3. Okay. So what you have to do is that tomorrow you will learn better from Dr. Arunabha Adhikari. But just for this purpose, I can tell you, you can convert a string to a number. So what you can do is that you just write eval x. You see, it's a value. You see, type eval is evaluation. So these are all built-in functions. Eval is a built-in function. Type is a built-in function. ID is a built-in function. At the beginning, you saw. So if I write eval x, okay, now it is a float because it is now 4.5. So it's a float. Well, so it's a float. So what you do is that when you give an input, if you give one input, that's fine. If you write one go, so x equal to, you can write x equal to eval, then put inside that input. It's like operator on operator kind of thing. You write a function on function. Okay, so you write eval inside that. So eval is a function inside that. At one go, you write. Okay, so enter something. Enter value of x, these. Okay, so it will show you. It is so good, sober that it is 1 bracket here, 2 bracket here, and 1, 2. Okay, now you write. It is asking x, you give, say, 3.4. Now it's fine. Now we write this. Now we type, it shows you this. So while you are working on Python 3 and we want to take input from outside, you will always be careful. Sometimes you would use int function also, but now it's better that you for this in int for integer. So you write eval. So it will evaluate the number. Also, I'll tell you, for a decoration purpose, you can actually write a /n inside that. That means it will prompt this this text, along with it will see that it is a /n. That means a new line. That means now if you do that, it looks better, right? Earlier, the number was earlier appearing here. It doesn't look nice. So now you see, enter the value of x. You give some 5.6. It will be 6. This is this. But if you write, say, x comma y equal to input, okay, and then you can also eval all these things you can write, no problem. But you see enter, enter two values, something you write, enter two values, and you say /n, /n, you write. Okay, so this and this. Let's see what it does. Two values, say 2, 3 I give. Is it x? Is it y? It is. It is. That's because instead, if you would not give this, it would not work. Because moment you evaluate, first I see, before I tell, I first see. Okay, let's what it does without evaluation. I give you this. Let's see, say 2, 3, something like that. No, it is giving an error because it takes 2, 3 as a string. As a string, so it will be like 2, 3. Whole thing would be put under screen, right? So like, let's see that. So suppose it is some say A. Okay. So A means it has, you have to, under that you have to put 2 things, 2, 3. So write A. So A is C. It's a string. Now you eval A. You'll see something comes. It is not a string, but it is another kind of thing. What is that? It is basically a tuple. Tuple means it is a collection of 2 items put under 2 first brackets, parentheses. The name of this is tuple. Like you often write in vectors, components, something like, or something, some component wise. So this is tuple. That means what we have done here, not here, here. Let me write here. What we have done here, the string we have evaluated. That means it has become a tuple, and the tuple means the collection of 2 items. And if you give a bracket, a first bracket or not, doesn't matter. If you write 2, 3 is also tuple. Okay, the bracket is not. Let's just like this. The bracket here is not necessary. But what it does is that it is called quote unquote unpacking. That means inside this whatever you have done, 2 things are there, 2 items, and you are unpacked. The first item goes to X, and the second item, so 2 goes to X, and 3 goes to Y. So this is again you will learn tomorrow, packing, unpacking, and all kinds of things then slicing, all etc. Everything you will know. Okay, so this is something of numbers and variables, and you can work with them. There is another construct. This another construct I can tell you. This is called, whoever known Boolean. You know this Boolean algebra. People who have little nowadays in 11, 12 in science, physics, people read about Boolean algebra, but doesn't matter. If someone who has not heard this name before, does not matter. Boolean is typically, I mean, this Ananda was telling yesterday, the computer understands only zeros and ones, because it has inside this, the processor understands ones, high voltage, low voltage, nothing else. Okay, so you have to work with some algebra where your base system is 2, unlike ours, where we work with a system with the base is 10. That means 0 to 9, 0, 1, 2, 3, 4 up to 9. So all the numbers are constructed out of 0 and 9. But in computer, in the binary algebra means you work with only 0 and 1. Okay, so you then convert from binary to decimal to binary, and also you can, if your base is 8, it will be octal. If your base is 16, it is hex, and sometimes I heard in Arab countries, the base sometimes were 60. That's why the 60 minutes is 1 hour, 60 seconds is 1 minute, and so on came. So that's what I don't know exactly. I have somewhere read, but you can verify it in Google. Anyway, so the Boolean algebra is nothing but the algebra of these things, zeros and ones. So here there are two constructs. One is true and one is false. So the constructs are true and false. You write true. So remember, the true, the color is different, right? And the true is capital T. The true is true. Okay. If you write, say, W something, because it doesn't know what is W, something or some name. Say I like area. It doesn't know what is area because I have not assigned the name. I have not tagged. But true, it understands because the color is also different, right? You may think this is the name of the variable, but not. True is a special Boolean construct. It's a true and there is a false. False. Okay. If you write print, you don't have to put them inside, although this is a kind of looks like a text, but you don't have to put them inside two quotes. These names are enough, like a James Bond. So true. Okay. So print true, it's true. Okay. But under this true and false, actually, I told you that the binary is between 0 and 1. So true is assumed as 1, true is designated as 1, and the false is designated as 0. So if you write true plus true, what it can be? It is actually now, when it is doing this algebra, now it is trying to first convert it as a number 1, and this convert is number 1, and then it is giving you the result. So it's like a ordinary calculation you would do. If you write true plus true minus false, it will minus doesn't work. Minus doesn't work. I think minus. Let's see. True plus.
No, it does work. False is 0. Right?
Oh, false is yes. Yes, false is 0. Right. I was going to check it for a moment. Okay, please stop me, the participants, whenever you are getting bored or you want to stop me. Stop me. I can give a break and then I can begin, because I have lots to say, but I don't know. Since I'm going through every detail, trying to touch every detail, so I don't know whether I can finish in 2 hours. Okay, true plus false is 0. Okay, huh? It's okay, false. Oh, sorry.
False is 0.
False is 0. So true. So if you write, now you understand, false plus false. False is 0, right? So it will be 0. So that's the thing. And remember this, after some lectures, 2-3 lectures, we'll show how you effectively, fantastically, you program with using true and false. So that's fantastic. Orunabodha can remember that we can program with in its random walk, quantity random walk, and things like that. We with true and false, you can show it that. Okay, so true and false. Remember these two special constructs. Okay, then there are other kind of built-in functions. One function is bool. So the bool, let's say bool. What is bool? You would write something out inside that, some number. Bool is a function, built-in function. It will give you true. That means bool is a Boolean function. Boolean algebra works with true and false, 0 and 1. So you write bool inside some 0 point something. It will give you true. You write bool minus something. So bool is always giving whatever plus, minus, etc. Whatever you are giving, it is true. But bool, if you write say 0, it is giving you false. Only that means bool is something, some function. Sometimes in your program you can use cleverly to check whether there is anything inside. To write bool and then it's a list, the collection of numbers. Of course, it will be true. Whatever inside something, some some food is there, so it is apart from 0, so it is giving you true. So bool is that way it works. Now there are other things. Okay, one typical representation of numbers I forgot to tell you. You see, the numbers are integers and float, but sometimes the floats you can write in some exponential format. Like you cannot always write all the numbers something 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 some numbers and something like that. You do not remember, but you write in powers of 10, right? You write the total number of say atoms in the entire universe is 10 to the power only 80. It's not only. If you write 80 zeros after 10, it will be enormous and the number is huge. So if you in science we always write numbers, big numbers. It's a good practice in computer also. In the float numbers you write in the power of 10. So you write 2.3 say e minus 10. That means if you write this, so it is basically tell you 2.3 into 10 to the power minus 10. Like if you write this, right, you will get to see all these kinds of things again and again when we get this is a float. So you could write it as 0.10 to the power minus 10. So it's 9 zeros and then 2 3. Okay, 0.9 zeros and then 2 3. That would be the number, but it could write it 0.00000 all these 10 to 3 etc. So that would be kind of boring work. So pain. So rather you write this way. Okay. So and now there are when you write programs, I told that I am actually introducing you. I'm not at the moment. I am not showing you any program. But at the end of the session, I will show you 2 beautiful programs. How you can write with this all this knowledge you are acquiring and proceeding. I think. Okay. So then numbers, variables, bools, etc., all are there. Strings are there. Then there are the mathematical operations are there. Then you can think of the comparison operators. There are various kinds of operators. You see, there will be and, or, is, etc. These are also operators in Python. You will cleverly use them when you build up your logical structure in your particular following some algorithm and things like that. You will use that. But for the moment, you can think I can just check with this. Suppose you write now I talk about the comparison operators. Comparison means it compares. See, equal to whether this equal to this, whether this is greater than this. If I write whether 2 is greater than 3, right? I'm not writing a program, just one instruction. What it will result? It will result in, of course, it cannot be, right? So it is false. If you write 2 greater than 3 greater than 2, of course, it is a true. If you write 2 equal to 3, it cannot happen because this equal to symbol means it will understand you are assigning 3 as 2. It's not that. That I used in while designating variables. So you have to write actually equal to. This you will remember always, because this is the mistake always beginners do. They write single double and they think like we think, okay, it is 2 equal to 3, or right if you think it is you are writing x equal to 2, that is okay. But if you are comparing 2 numbers, something, so you want to compare this x2 equal to 3, what it can be? It can be false. So it will answer you in booleans. So that can be cleverly used. I will show you how to write a program where you can actually enumerate how many prime numbers are there between a certain number, between certain number to certain number. Okay, so there I will actually cleverly use that. So if you write 2, there is another comparison operator. You can write exclamation symbol and then equal to 3. That means actually not equal to, because not equal to symbol is not here on your keyboard. So this is 2 exclamation symbol equal to 3, and of course it will be true. Of course it is not true. Okay, it is not the thing. So it is true. And later many more operators will come into picture, but at the moment we can only be satisfied with that.